All right, let's do this. Hello, everyone. Thank you all for joining. It's time for another exciting lightning talk. I'm Parag Katkar, your host for tonight. I'm the head of consulting practices at InRhythm. InRhythm is a modern product and technology consulting firm, and our practitioners they stay on top of the latest technology trends in the industry. And every other Thursday at 5:15 p.m. Eastern Time, one of our practitioners shares their knowledge of these exciting trends with you. And this week we have one of our senior iOS engineers, Vadym, with us. He's going to give us an overview of SwiftData. SwiftData is a powerful framework for data modeling as well as data management for your iOS applications. And I'm super excited to learn more from Vadym today. So without further ado, let's get it started, Vadym.
Thank you, Parag. All right, so tonight we're going to talk about, as Parag mentioned, SwiftData. And the first thing I'm going to discuss is kind of an overview of data persistence in modern iOS apps in general. Um, Modern iOS apps heavily rely on data persistence, and you can have all kinds of different levels of data persistence. You can have simple stuff like if it's a straightforward to-do list app that you're, I don't know, creating for a tutorial or maybe launching with a cool design on the App Store. You can have a very simple persistence layer to the point where you can just store JSON objects locally on disk, or even a plist file, which was kind of the way to store data in the early days of iOS and the early days of iPhone, of course. But as things have evolved, we got a couple of different ways of doing more advanced data storage, and things like core data and Realm all showed up on the scene to help us with those challenges, especially when it came to doing complicated data model structures and relationships as well. And of course, since this talk centers around SwiftData, we'll of course cover that and the reason why it was released in the first place. And that has primarily to do with the advancements that Apple has made over the years in Swift itself as the language evolved, and of course the release of Swift UI in 2019. Even though it's evolved and changed throughout the years, some of the frameworks did not keep up as much, especially some of the frameworks that we would have to use within Swift UI, such as core data. Of course, there were a bunch of different improvements over the years that have made using core data a little bit easier in Swift UI compared to the predecessor of UIKit, but a new approach was still needed, a more modern approach. So first thing I'm going to talk about is going back to that simple data persistence layer. iOS offers you a way to store files in all kinds of locations. You can use the file manager to control where the content is stored. You can have access to the file system and make changes to the folder structure. You can rename folders within your for your app's file system. And most importantly, you can figure out where you want to store the data. You can store it in all kinds of formats, but the more common ones that were used in the early days, and even for simple applications, are storing direct JSON files and plist files. And as I mentioned earlier, it does work great for simple apps, but it lacks features. It doesn't give you the ability to do complex data relationships and data structures. And there's also a huge risk for security, because you can, if the phone is unlocked, there are ways to extract locally stored files that are bundled within the app's container. So if a requirement is to have a database that's more robust, has lots of features, is fast, and lets you create complex data relationships, Realm and Core Data are the top choices on iOS platforms. iOS, iPadOS, and I think Realm at this point only works on iOS and iPadOS. I think they made a version for macOS, but it doesn't yet exist on watchOS and other platforms as well. But Realm started out as an open source database. It was intended to be a fast and lightweight alternative to Core Data. Unlike core data, Realm does not use an SQL database under the hood, so it's known as a NoSQL framework. And the way it stores it is actually, interestingly enough, very close in format to that of a standard JSON file. The way the framework ends up linking all of those data storage objects together to present it back to you in the form of your models is kind of like the cool part about the framework. Additionally, that data store that Realm creates on disk, since the framework is written in C++, so you can argue that it's a frankly neutral language. It'll run on both iOS and Android platforms. The database binary that is generated is effectively platform agnostic. And Realm offers a syncing service where you can actually sync that database across platforms, which is pretty cool. And even if you were to just build some sort of user interface for that, for grabbing that data store and airdropping it, or doing a file transfer to an Android app, it would actually be able to compile just fine and open that database up on another platform, which is definitely a cool feature. But since Realm was supposed to be an easier to use alternative to core data, there are some features that are still lagging behind core data. For instance, one of the major gripes with Realm is that if your data structures change often and you have to do migrations frequently of the database, then setting up that migration code is a little bit more of a hassle than it is with core data. But they are steadily catching up. Being an open source framework, Realm is much faster at developing, to the point where over the years, core data had to evolve as well to kind of keep pace. Now, speaking of core data, this framework is, in my personal opinion, I think gets a bit of a bad rap amongst iOS developers. If you talk about data persistence, many developers will kind of cringe when you mention core data. And that probably has to do with the fact that it's a very old framework. And unlike other frameworks on iOS, such as UIKit or SwiftUI, it's hard to learn that framework as you go. You kind of have to understand how it functions and how it's put together. It's extremely fast in a single thread process, but it also shines when you use it in a multi-threaded environment. However, it can lead to a lot of glitches and bugs and data inconsistencies if you are not careful about how you're writing that code. But core data as a framework itself is obviously a first-party framework developed by Apple. It originally came out in 2005 for Mac OS X Tiger, so that's going quite a ways back. And due to the age of this framework, it's become really stable. The core of the framework is super stable and very mature. The API had to evolve over the years, but it's much better than it used to be. But this day, it's still kind of a hassle to set it up. You have to set up the core data stack, like the managed context, the objects that will retrieve data and save data. You have to make sure that at every step when you're modifying your database, you save the changes to that database. So there's a lot of things that are moving around. Additionally, when you're designing your model structures, not only do you have to write the code for it, but you also have to use Xcode's visual model editor to create the schema for that model, where you can set up a complicated relationship structure with your properties and objects. If done well and correctly, it can be very beneficial, but unfortunately, the API complexity tends to be a bit of a barrier for utilizing the framework. And that brings me on to SwiftData. So SwiftData was released at WWDC last year in 2023, and it's designed to be a simple to use, fast and powerful data storage framework. And right out of the gate, the cool feature of it is that it's available across all platforms that Apple has. iOS, macOS, tvOS, watchOS, and of course, the up-and-coming VisionOS that's going to launch soon. The the cool stuff about SwiftData is that it takes advantage of modern Swift features such as macros. It works seamlessly with SwiftUI, and in the demo, I'll showcase that seamlessness in a second. And it allows us to have a framework for a very crucial aspect of many modern iOS apps, whether they're legitimately storing complicated models local on the device or using a fast database system local to the device for caching purposes. Whatever the use case is, SwiftData makes it quite easy to interact with the data, manage it, delete it, update it, and of course, track changes and keep the data up to date. There are a few downsides, so it's not as typical with a lot of these frameworks. There's not ever all roses and sunshine. One downside is that it's only available on iOS 17 and of course the corresponding versions of all the other operating systems that Apple has released last year. So if your project requires the use case of N-1 for the software version, for iOS version, then you might not get to use it right away. But once you do get to use the framework, the benefits are very, very significant. And by the time many customers can take advantage of SwiftData, given the sometimes requirements of having to support older versions of iOS, there should be more developments in the framework to support additional features that are coming from the core data side. And such as like executing a complicated query and then monitoring for changes within the database that's local to the phone. And the last thing I'll mention about SwiftData, which is, I think, its coolest characteristic, is that without core data, SwiftData would not exist. And it's not that SwiftData took inspiration from core data. SwiftData literally runs on top of core data, which I will showcase as well. SwiftData is essentially a high-level API that is designed to be robust and easy to use, while interacting with a reliable and mature database system that will be quite stable. So let's switch over to a quick demo, and I will showcase some of these features here. So for this talk, I created a quick little application designed to store a list of your favorite cars. So you can think of it as like a simple to-do list app that most of us have created in the past when we were learning the platform. So right out of the gate with SwiftData, when we set it up for the application itself, what we truly want to have is to make sure that when the app launches, it creates a model container so that it generates the database, creates all of the schemas and everything that the database needs to actually function properly. And we do that by simply importing the framework and applying a model container as a view modifier to the window group. And when the app launches, this model container modifier function will create that container and generate the database. Now, you can see here that I'm passing a model of car.self that is a SwiftData model, for lack of a better word, that is going to be the primary model for this container. What's really cool is that if we look at, sorry, I just meant to do this one instead. If we look at the actual model container function, this is designed to take in a few additional parameters. So just applying a simple model container and saying that, hey, we're going to mostly store just one model type is good enough. But if you need more functionality, you can always configure this model container and take in a schema. You can even import or pass in an array of model objects of SwiftData model objects, and you can customize all kinds of different features that you would need. Now, most notable here for me is the is autosave enabled, which is by default set to true. And what's cool about this, as I mentioned in core data, whenever you're modifying the model container, or you're modifying the managed context as the framework has the object that you interact with the most, when you're modifying the files and changing things around, you always have to make sure you save the context. Otherwise, whatever change you've made will not be reflected in the database. And when you go to relaunch that screen that pulls the data or restart the app, you're just going to see old, out-of-date information, and it's going to appear as if there's no bug, but you really just only forgot to call the save function. With SwiftData, we don't need to worry about that. By default, autosave is enabled. And there's a whole bunch of other features here that I am not sure if we have the time to go into, but in the future, we could maybe discuss those as well. But in any case, we simply create a model container, pass in the model that we want to store in our container, and we go from there. Now, I explicitly wrote the initializer here so that we can print out the application support directory for this specific simulator, and I'll showcase in a second where that's useful. But first, I want to show the actual model for that we're storing here. So this is our simple car class. It's got 3 properties: a brand, a model, and a vehicle type. The vehicle type is a simple enum that just has typical cases like car, SUV, pickup truck, race car, motorcycle, etc. To store items like this in SwiftData, if you're trying to store complicated model types like custom models or enums, which you can store in SwiftData because it supports all the types like string, integer, double, float, etc. You just have to make sure that your custom model types are codable if your actual model, like you see here, the car class, uses that type, such as the vehicle type enum. And from there, I just have a support function here to draw an emoji for the particular car type, just to make the user interface a little bit more interesting. And traditionally, when you write a model object like this, you usually just start with a struct so that you can build it out and see if you need any more advanced features, right? Like observation or some properties that are going to change over time, things like that. And one of the requirements for a SwiftData model to be usable is so that it's a class. And what's also really, really cool is when you apply this @model macro, it generates a whole bunch of interesting features for us. So if we expand the macro, we get additional declarations above our properties. So they're all persistent property types. The underscore here just means this is still a private API that Apple uses on their internally that we as developers don't have access to. And from here, you can see that there's a bunch of different things that are being done behind the scenes, such as creating the schema metadata for the particular property types, and also the key paths, so that we can use key path syntax whenever we're trying to either sort through our lists or do a complicated query. We can use those key paths to help make our syntax a little bit easier to read. So all of this is done by using Swift's new macro feature. And we're probably not going to get into the details of that tonight, but this macro feature is one of the main, like SwiftData is one of the main frameworks at the moment utilizing them from Apple. So one last benefit I'll mention before we get to the actual demo: when you apply an @model macro to your object types, if you have any sort of observation needs, like let's say these properties for model and brand were published properties and the whole class was an observable object, or if you're even using the new observation APIs, when you apply an @model macro, you actually don't even need to write that as code. You can delete all the @published or observable object declarations in your model object, because SwiftData and the @model macro imports the observation framework by default. So you kind of get that for free when you utilize SwiftData, which is a nice benefit. Okay, and just to cover the code one step further, it's a simple list that's going to show just the text for the brand and the model. And there's some buttons here to help me add the data and remove it as well. But let's run this and see how this ends up working. So the user interface is pretty straightforward. You just have the title and the plus button. So if I click the plus button, we can type in a brand. So we can do something like Mercedes. But being an F1 fan, I'm probably going to write a slightly different model that may not be easily recognizable, but it's the Mercedes W11, which is one of the fastest F1 cars made in the last decade and one of the most dominant. So we have this race car. Let's maybe add another one. Let's try and use my hardware keyboard to make the typing a little faster. And this is the second most dominant race car in the last year in F1. And I promised them to stop with the race cars. So let's add a Ford Mustang, because Mustangs are awesome. Okay, and this now is a car. We can also add maybe let's throw in a Tesla for funsies and call this Model Y. And that'll be, even though it's not really an SUV, more of a crossover, but we'll call it an SUV. So here we have a couple of objects listed here, this standard user interface. Of course, if I stop the app and then run it again, the data is obviously persisted because this is a SwiftData demo, but I just want to make sure that this is, referenced. So now that we have this path to our simulator data storage, I can right-click on this URL and go to Services and Open, and we can open this in Finder. And this is the application support directory for the currently running simulator. And you can see here, there's a default.store file and a few additional default.store files that are support files for things like metadata and all the other stuff. This is the file for the core data database. So if I right click on this and open it with an app called Core Data Lab, it's a pretty cool app that's on the App Store. It allows you to browse and view data storage containers in core data. And you can, of course, go and get an app like DB Browser. It's a free application. If you just Google search DB Browser online, it also lets you do this. But this also has a kind of a familiar Xcode-esque interface, and it shows you some slightly simplified mechanics here in terms of the user interface. So if you look at the sidebar here, we have a list of entities. And because we're only using one for this demonstration, we have the car entity. And the car entity here, we have a couple of properties listed. Of course, the brand, the model, and the vehicle type, which I set my vehicle type to be an integer. So you can see why it's saying vehicle type equals 0 through 1 and 3 a couple of times. Now, what's kind of cool is when you're browsing the database for core data, this app cleans this up a little bit, but you can see slight traces of here. This Z_PK is the way that core data actually labels the fields within the SQLite database. For some reason, Apple decided that we're going to add a Z underscore in front of every property. The reason I mention this explicitly is because if you open the data store object in DB Browser, you will see Z in front of every single property name. But this app tends to clean this up a little bit. So here we can see the data storage. And again, this is a core data storage file, and we're able to interact and create it in SwiftData. So switching back to Xcode here and the simulator. If I swipe this last car, the Model Y, and we delete it, we can, of course, remove it. And if we go back to Core Data Lab, you can see here the app is already updated and is listing the final object as nil. But if I refresh it and it reloads the file, you can see that the data is gone. And the code for this is extremely simple. When you create a list and you do a for each, you can create an on-delete action because you're basically recreating the standard table view that you would do in UIKit. And the on-delete action allows you access to the index set for the specific row. You can do a for each on that index set, pull out the individual index, and index your array and delete the from the model context the correct car object from your array that you're using to render this whole list. And notice how here we only have the model context and we calling a .delete and passing the object that we want to delete. There's no additional code needed for initializing the model context except for a small property listing up top, which I'll show in a second. And there's no code for saving the model context. You just interact with it and you do whatever operation you need to do, and you're not risking forgetting to save the context in any case. So here's how this also works. So if you have, if you need to import a model context, you need to use it in your file, you just simply do an add environment and pass in a key path for model context, and then you can call it whatever you feel is appropriate for your application. And now you have access to the core data store through SwiftData, and you can interact with it, save models, delete them, etc. Now, for this screen, because this is the main content view that lists all of these vehicles, we also have a add query property here. And this query takes in a sort. Now here, the sort is just a basic, I'm going to sort all of this data by the manufacturer, the brand of the vehicle. But this could be initialized in an initializer. And you can utilize the whatever user interface you want to indicate that you can sort the list in your view. And you can build a complex or a simple sort descriptor and allow yourself to change different sort orders based on different properties, like brand, you want to sort by vehicle type, or you want to sort by the model, etc. So this is all possible with the add query property here. And other than these building blocks, the only two other things that I wanted to show here is the creation of a model. So here, when I press the plus button, I get this modal here that lets me add branded model data and select the type as well. Once you start entering something here, like you enter the first letter and the first letter of a model, you see the button gets highlighted. Just checking to see if the string is empty for this simple case. But once you press the button, you create your new car model or whatever model you're saving, just like you would in any other context. And you simply call model context, the one that you extracted through your add environment property, and you call the insert method with that new car. So you can see how inserting, deleting, and creating and also retrieving is very, very straightforward in SwiftData. And lastly, when we go to content view here, for the content view, and I'm going to stop the simulator here and just make this full screen, and let me bring up the canvas. So one cool feature that model containers have is that you can actually apply a model container onto your previews. So if you like to use previews for development, and it's a big part of your workflow, which is quite common these days, once you're utilizing previews, you obviously want to have access to your model container so you can actually interact with your preview as you would with a normal app without having to launch the whole process on a simulator. So when you apply a model container to your preview, you can specify that it should belong in memory only. And if you are developing your app through previews and you're expecting your models to kind of change around, the benefit of using an in-memory model container for your preview is that you won't be creating a new model container every single time. And if there are changes to your properties and you haven't written the schema code for migrating data, you will not, you'll probably run into a bunch of errors. So when using SwiftUI previews, it's best to avoid creating multiple model containers as you're launching your preview and interacting with it. So using a model container this way in your preview is a very effective way to do that, while still getting a good glimpse as to how your app is going to function with SwiftData. Okay, and with that, that's pretty much it for the demo. To finish off the talk here, there's a couple of links that I've provided here that are extremely good for getting familiar with SwiftData and diving more into detail. Apple has really good resources from their WWDC 23 sessions. So Meet SwiftData is a really good one. Gets you kind of a brief overview of how the framework works, including some of the things I covered today. And it also gives you access, like if you look at it through the developer app, you can see the related videos. One of those is Build an App with SwiftData, which is a Apple's multi-platform app. So the code that is written by the engineer in the video is run on macOS, on iOS, watchOS, and even tvOS as well. But all of the sessions that have to do with SwiftData are very cool and a good resource. And another resource I included here as well, which helped me understand the framework even further, is a guy named Stuart Lynch on YouTube. He's put together a really awesome playlist. It's, I think, around 4 hours in length in total. So it's kind of like one of those coding sessions for a rainy weekend. But it's really awesome, very detailed, and highly recommend viewing that YouTube series as well. So with that, we can go into questions. And if there are no questions, I'll hand it back over to you, Parag.
I have one question. So, so what are the possible ways we can sync data with any remote services? I know there's a CloudKit option, but I never explored that. So, yeah. Are there any concerns around syncing the data or something?
So that's a great question. So SwiftData works with CloudKit out of the box, but you don't have to, like, if your concern is, I guess maybe if you could clarify the concern, if the concern is putting data on CloudKit, you don't actually have to use it. But if your app utilizes CloudKit heavily, it's very seamless. There's not a lot of boilerplate code. You just have to make sure that your models are labeled as @model, and you add the appropriate things you need for CloudKit, and it's pretty seamless. I didn't dig into the details myself for the talk, but CloudKit is supported natively by SwiftData.
Okay, and can be another way to sync it, like with any third-party remote service like AWS, Firebase, or any private cloud or something?
Kind of like Realm does? Is that what you mean?
Yeah, I mean, because if something is being stored locally, definitely if you delete the app, your data is gone. So what can be like other custom way to like sync up your data other than CloudKit? I know CloudKit is from Apple. Is there a way like to sync it with any other third-party cloud as well? Azure, AWS, or any cloud service?
I'm not 100% sure about that, but I can look into it for if we ever do a more deeper dive into SwiftData. I could look into that for the future, but I'm not 100% sure. Yeah.
Cool. Yeah, that's it.
I say something. So let's say that we have an existing persistent data framework there, and you want to migrate over to SwiftData. Do you know if that migration is going to be complex, or is it going to be from scratch, or is there any way to do any migration?
So SwiftData offers data migration capabilities, but from the context of if properties change and you have to update your property names, or you're adding more properties, like you can migrate your previous data container to a new version of that. But that's like within SwiftData. But if there's an existing layer with Realm, I'm not sure how much work that would be, because you're technically replacing the database system from Realm to SwiftData, which underneath is core data. But I did see on Apple's WWDC videos that there is a possibility to migrate your old core data store over to SwiftData, because it's still core data under the hood. It's still the same data store object. So I can see that being a possibility, but I haven't looked into that detail per se.
Okay.
No,
Awesome.
but
Thanks, Vadym.
Yeah,
that's a
anytime.
good question, and that's very relevant for all our customers, right? So it'll be a good idea for them to look into that and probably add it.
Absolutely.
Yeah, maybe we'll have a part 2 deep dive.
Yeah, definitely.
Cool. All right. So let's wrap it up then. First of all, thanks, Vadym. Excellent talk. And our next talk is going to be on WebAssembly using Rust. And it's going to be by one of our senior software engineers, Suman Kumar. I'm really looking forward to that. Make sure you guys mark your calendar for January 25th. That's when it's going to be. So it's 2 weeks from now. And thank you all once again for joining. Have a wonderful evening, and I'll see you guys next time.